Good morning. In this video, we are going to talk about proposition 42. Okay, so it is a pretty typical Euclidean construction problem. It declares that if we are given a triangle ABC and a rectilineal angle alpha here, then we are able to construct a parallelogram which is the same as this triangle in this rectilineal angle. Okay, so let's give it a proof. So first of all, please recall proposition 10. We are able to bisect a finite straight line. So let's assume we bisected AB at the point of D, okay? And then recall proposition 23, we are able to duplicate a rectilineal angle with a given straight line and a given point, right? So let's assume this is a given rectilineal angle, and let us construct this angle which is equal to alpha. So this is also alpha, okay, because of proposition 23. And then please recall proposition 31. We are able to construct parallel lines through a given point and parallel to a given straight line. Okay, so let us construct a straight line here through the point of B that is parallel to the side of this angle. Okay, so they are parallel. And let us construct another straight line through the point of C that is parallel to AB. Okay, so they are parallel. And let's suppose these points are A, B, C, D, E, and F. So which means this straight line meets them at E and F respectively. So we know that EF is parallel to DB and DE is parallel to BF, which means DBFE is a parallelogram, right? Okay, so in the next step, please recall postulate 1. We are able to construct a straight line by joining two points. So let us join CD. Okay. Great. And in the next step, please recall proposition 41. So if a triangle and a parallelogram have the same base and they are in the same parallels, then the parallelogram will double the triangle. Okay, so please have a look at this image. This parallelogram and this triangle CDB, they have the same base DB here, and they are in the same parallels. So which means triangle CDB equals half of parallelogram DBEF, correct? And what we know, the point D bisected AB, so AD must be equal to DB, and AD equals to DB. And then we can apply proposition 38. If two triangles have the equal base and they are in the same parallels, then they are equal. Have a look at these two triangles, ADC and DBC. They have the equal base and they are in the same parallels. So we know that triangle CBD equals triangle CAD, correct? And if we combine these two equalities together, we can imply that triangle CAD is also equal to half of parallelogram DBEF. And if we add ADC and DBC together, we will know that triangle CAB is equal to the sum of triangle CAD plus triangle CBD, which is equal to half of parallelogram DBEF plus half of it, which is equal to parallelogram DBEF. And that is the end of our proof. So we have actually constructed parallelogram DBFE, which is equal to the given triangle ABC on a given rectilineal angle alpha. So they are equal, right? In this next video, we are going to talk about proposition 43. Thanks for watching. Have a good day.